Hi, my name is Osmond. I came from the student chapter of Tulancingo, the Politécnica University of Tulancingo. Here is my partner Alejandra and my partner Julio. In our experiment, we will demonstrate some phenomena that occurs in light where it acts as a wave. As we know, with waves, we can make interference. With the light, normally we'll have a pattern. If we have two beams of light of the same characteristics, we will have interference. But one way to make interference is with two water waves. In this case, we take two droplets, and we can see in the center, how they interfere with each other. They interfere to each other and they make a pattern in there. If we want only one, we do not have interference. But also there is another phenomena that is responsible of make the blurry edges in the shadows. That happened with diffraction. The diffraction is a phenomenon that occurs when the wave touch, in this case the light touch an edge, and it changes its direction of propagation. So we need to make a plane wave that will come into the slit. The slit will be the edge, and will come out as a spherical one. So the trick here is trying to make a plane wave, and in this place we will see a little one spherical wave that is not only propagate in this direction, but in any direction. They turn them off, but it's more easy to see it in this way with an angle. We can see a little spherical wave coming out through of the slit. Also, my parent has been playing with the light. We know that the white light has three components. When we put the blue, the green, and the red light, we will see that the milk that is dissolved in the water emits a white color. But what happens if we take off one component? Here we only have green and red light, and it comes out as a little yellowish light. But when we have only, can you make this work? Only blue and green, we see a cyan color if we turn off. Here we have only red light and blue light, and we see a pink color coming out of the water. So in order to see that is red light, what is on the top, here we have the red light only. Also, we know that the light does not only works as a wave, instead it can be treated as a ray. So geometric optics can be illustrated working with normal water and a droplet of oil. In this case, we have many droplets that emulates a positive length that converts the light at a certain point. That point is named the focal length. So each one of them is of a different size. The bigger it is, the longer the focal length it is. So if we take a droplet of oil, a little tiny one, and put it in the water. We can see how the light converges in one point. The droplets will want to merge into one bigger one. So also, we can see that the big ones has its focal length far away from the table. But what happened with the little ones that focus faster? We can use them to illustrate the coma aberration that happens when the object is placed off the axis. In this case, we take the source and put it off the axis, and we can see how the coma aberration works. They does not only focus in one point, but it kind of spread out of the axis. One of the important things here is that we can make this experiment with very cheap materials and easy to find, so the kids can come back to their homes and do it by their own with their friends and learn more about optics. And one thing that the child loves is the lasers. They always want to play with lasers. So we have a demonstration of total internal reflection, which is a phenomenon that happens in the optical fibers used to make the data using in communication to transmit data. So we are pointed the laser from down to the top, but it reflects on the surface. We can see here a reflection, in the bottom another one, and here is another reflection, and it comes out of the recipient to the floor, to the table in this case. And it's something that happens in optical fibers. So here we have a demonstration of fluorescence. The fluorescence will act only with certain wavelengths and with certain materials. In this case, we have tonic water with quinine in it, and we have normal water. If we turn off the UV light, we can see how the tonic water shows a different color of light. The normal water does not have fluorescence in it, but the tonic water, it does. And when we turn off the light, they look like the same, but they are not actually. So all these things are easy to do in your own home. You can only need a few materials. It's fun to make this kind of experiments and have a little fun with optics.